we have just seen, so here's a summary of what I just said. When the equation of the line is written in the form, put B, I think everywhere we've been using K. It doesn't matter what you use there, but I'll put a K to make it consistent. Okay. When the equation of a line is written in the form mx plus k or mx plus b or whatever that is, that's called the gradient intercept form of the line. And the reason is obvious, given what we just said, because we know that the m is the slope and the k is the intercept. As I say, sometimes you'll see b there, or no, whatever it is, the constant term is the intercept. So that's called the gradient intercept form of the line. So this says, determine the equation of the line with your gradient of -3 and which crosses the, that's not what I wanted, that wants to be the y-axis sitting in there, crosses the y-axis at the point 0, -2. Okay, I've got x equal to 0 there, so that's definitely crossing at y -2. So in here I can say the equation of this line will be y is equal to, its gradient is -3 and its y-intercept is -2. That's all we have to do. Just understand the terms and put them in the right spots. So I guess in here I could have said, look, m is equal to -3 from there. K is equal to -2 from there. The second example's a little bit different. It says, here's the equation of a line, determine its gradient and y-intercept. Well, that's easy to do because all I have to do is rewrite it with y as the subject, and then I can read off the slope and the y-intercept. So I'm going to rewrite this with y as the subject. So here we go. I have 2x plus 3y minus 5 is equal to 0. I'm going to bring the terms that don't involve y over to the right-hand side because I'm trying to make y the subject. So I have the terms involving y on the left-hand side, and on the right-hand side I have the terms not involving y. So minus 2x, I've subtracted the minus 2x and added the 5. Lastly, I divide by 3. So I have y is equal to minus 2/3 x plus 5/3. That's now in gradient intercept form, and so I can read off the gradient of the line and its y-intercept. So the gradient will be the coefficient of x, which is minus 2/3. So that says every time I go across one unit, the graph goes down by 2/3. That's what that says. It has a negative slope. And its y-intercept is equal to 5/3. So it cuts the axis at the point 0, 5, 3. 5 on 3. And in fact, given those two things, I can actually draw its picture. Okay, the last example says, determine the equation of the line with a gradient of 2 and which passes through the point 2, 3. So, I want to find the equation of a line. It's y is equal to mx plus k. My job is to find m and to find k. That's what I need to do. Once I know those two things, then I have my equation. Now, I'm given the value of m. So I can say, since m is equal to 2, I know my equation is y is equal to 2x plus k. So I've got the m. My job now is to find the y-intercept. Now it doesn't tell me where it cuts the y-axis, so I can't read that straight off. But it does tell me it passes through the point 2,3. And if it passes through the point 2,3, when x is equal to 2, y equal to 3 has to satisfy the equation. So I can say, since this thing passes through, since the line passes through 2, 3, when I'll just put it in. When since it passes through that, when y is equal to 3 and x is equal to 2, that equation has to be true. I'll just write it here. The equation must be true. Equation is true at this point. That's my thinking. In there to there. And the only way that equation can be true at that point is if k is equal to -1, 3 minus 4. So that tells me that k has to be -1. And so the equation of the line, so the required equation is y is equal to 2x minus 1. And the beauty of this question is that I know whether I'm right or not. Let's have a look. I know the slope, it's written there, it's 2. And I can check, does it pass through the point 2,3? Let me put x equal to 2. 2 times 2 is 4. 4 minus 1 is 3. Yes, it does. So 2, 3 lies on the line. It lies on the line and has a slope 2, so therefore I've got it right. I'm happy.